So I want to make sure we look at it together. So this is 3x squared minus 2xy minus y squared all over x squared minus y squared divided by 3x squared plus 4xy plus y squared. We can factor all of this. That's not a problem. When we see the y squared at the end, what does that tell us about our two last terms? Yeah, our two last terms have to have y's in. That's all it's saying. There's no other difference when we're factoring. Okay? So if we want to factor 3x squared minus 2xy minus y squared, if our first term here is 3x squared, what do our two first terms have to be? Yeah, 3x and x. Our last term here is a y squared. So our last terms have to be y and y. Now we want to make our outside and our inside give us a negative 2xy. So our outside is right now a 3xy, and our inside is an xy. So what do the signs need to be on there to give us a negative 2xy? A negative 3xy and a positive xy. So we'll make the signs happen. Okay. All over x squared minus y squared. How will that factor? Yep, x minus y, x plus y. For the most part, I've seen you guys get that just fine because it's a difference of squares. Times, what will be in the numerator here? Yep, 1. Okay, and then we need to factor 3x squared plus 4xy plus y squared. So our first term is a 3x squared. So what do my first terms have to be? Yep, x and 3x. Our last term is a y squared, so what do the two last terms have to be? Y and y. Now when we look at the outside and the inside, we want it to be a 4xy. So the outside is a xy. The inside is a 3xy. What type of signs do we need there? Yeah, these both have to be positive to get a 4xy. So I'll make these both positive. Okay. So no different than factoring when we just have a number at the end. We just have to include y's. So now what will all cancel? Okay, so the 3x plus y will cancel. What else will cancel? Good, the x minus y will cancel. And then we are left with a 1 in the numerator. And then we have an x plus y times an x plus y. So our first terms would be x squared, yep. X squared, what's the outside terms going to be? xy, the inside terms would be another xy, right? And then the last would be a y squared. So when you combine your outside and your inside together, what do you get for this one? 2xy plus y squared. There's our simplified. Is that okay? All right. I think I've got one last problem that has multiplying and dividing all in the same problem. And variables. Okay. So this has a to the 4th minus 81b to the 4th all over a squared c minus 6abc plus 9b squared c times a plus 3b over a squared plus 9b squared, and then divided by a squared plus 6ab plus 9b squared all over a minus 3b squared. I think it does look kind of fun. No? So the only thing that's different about this is we have variables in all the locations, and now we have 3 things. Okay? But we're still going to solve it the same exact way. We're still going to factor everything. And when we see divide by, we're going to write it as multiplied by the reciprocal. Okay? But the key here is going to be able to factor everything down. So let's start with the first one. A to the fourth minus 81b to the fourth. Yep, it'll be a squared minus 9b squared times a squared plus 9b squared. We know that because it's a difference of squares. They're perfect squares. What do you notice about this denominator? A squared c minus 6abc plus 9b squared c. Is there a term in there there's a c? So the first thing we actually want to do for this is we want to take the c out. Okay? So can we visualize this without the c and factor it at the same time? Okay. Because it's the greatest common factor, and we always want to take the greatest common factors out first. So we're going to take the c out, and then we are going to try to factor this. So if we take the c out, our first term is our a squared. So what do our two first terms have to be? A and a. Our last term is a 9b squared, and we're trying to get the outside and the inside to be a minus 6. So what would work for that? Yep, 3 and 3. So a minus 3b and a minus 3b. Why do they both have to be a minus 3b? Yep, we want to get a minus 6. Okay, so there's the first one. Times, is there anything we can do with this middle one?
The difference of squares is like a 9.
Oh, is it a difference of squares though? It is, but it's not a difference.
Yeah, it's not.
So there's nothing we can do, so we just leave it as is. Okay, and the last one we are dividing, so we want to change it to multiplying. A minus 3b squared, is that already, it's already factored. So a minus 3b squared. How about the a squared plus 6ab plus 9b squared? Yeah, what do the two first terms have to be? A and a. We want a 9b squared. We want the outside and inside to give us a 6ab. Yeah, plus 3b and plus 3b. We don't quite have it all factored completely. I see one other thing we can factor, but let's cancel what we can right now. So what can we cancel from this step?
A plus 3b.
Okay, so we have an a plus 3b here. So we can cancel it with one of our a plus 3b's there. What else can we cancel? Yep, a squared plus 9b squared. We've got one there. We've got one there. We can cancel those.
A minus A minus 3b and a minus 3b.
Okay, so here we have a minus 3b squared. So we have two of them. And how many do we have down here? 2. So can I cancel both? Okay, so we'll cancel both of these with our 2 of them up here. And that's all we can do right now. But we do have an a squared minus 9b squared. Can that be factored one more time?
Yeah.
How can this be factored?
A squared
A minus 3b times
a plus 3b.
a plus 3b. That's the only thing we had left in the numerator. So now the denominator, we have a c left, and we have a plus 3b. Okay, and then from here we could cancel the a plus 3b's out. And so we are left with a minus 3b over c. This problem is the absolute hardest problem I would ever give you. Probably wouldn't give you one like that on a quiz or a test, but now you've seen it.